Okay.
They should be. I don't know why we're talking about it.
Oh. Hello. Hi. No problem. Will do.
I hear all this stuff
Bye.
already when my dad comes home from work.
Hannah, your presence is requested in the AP
My
office.
dad works in what we literally just read.
Okay.
Works for night.
So let's go through this here. Number one, we are asked to subtract these two imaginary numbers, okay?
No, we're asked to simplify.
Right, or that's true, we're asked to simplify, which will involve subtraction, right? So we have a minus sign in front of parentheses. I'd encourage you to change that to add and then the opposite. So make it a -4 and a +5i. Then when we go to combine or simplify here, we're just going to combine like terms. So the 3 will combine with what?
3's going to combine with
The -4, right? And so we'll get -1. And we have a -9i plus 5i. Those are also like terms. And that'll make that a -4i or plus -4i.
Yep.
Okay, and so there's our answer.
-1 minus 4.
Okay. Number 2, we're going to multiply here, right? We can see there's multiplication between these two. When we multiply, we're going to have to use like FOIL. Yeah. So 2 times 7 is going to be 14. 2 times 2i will be 4i. Okay. -7i times 7 is -49i. And then -7 times 2i will be -14i squared. Okay. But we're not done yet, because we have some things to combine here. So what are our like terms that we have right now?
4i and -49.
Yeah, 4 and the -49. So 4 minus 49 is -45i.
Yep.
But one more thing to combine here to simplify, I squared is the same as what number?
-14.
It'll be -1, okay? So yeah, -14 times -1, which makes this a +14, which you can add with that 14 there, and we'll end up with a 28 minus 45i.
How did you go from -14i squared to -14 times -4i?
Remember, I is equal to the square root of -1. Oops, I'm off the screen. There we go. I is equal to the square root of -1. So if I take I and square it, that would be the square root of -1 squared. And when you square square root, it cancels out. You're left with just the -1 there. Okay? So then the I squared is just -1. Okay? And you get this.
Oh, so you don't bother with the 14 also, you only bother with the I being squared.
Only the I is being squared here. If the 14 was being squared, you would see parentheses around this. So only the I is being squared there. Okay? All right. Question? Okay.
Do you think the whole time packet will be recorded or just what we cover in class?
I'm going to record what we get to in class today, and then I'll finish tomorrow, and that'll between those two videos you'll have the whole thing. Does that answer your question?
Yeah.
Okay. So remember, folks, what other things you can do here? This is all can be done in your calculator. So parentheses 3 minus 9i, close parentheses, minus 4 minus 5i, close parentheses, and there you get -1 minus 4i. How do you do I?
Yeah.
It's second decimal point. Second decimal
Oh,
point.
there you go.
And you do the same thing for multiplication too. All right, number 3, you cannot do in your calculator. Okay, but what does it mean to square something?
That times itself.
Multiply by itself. So we're going to do 3x minus 8 times 3x minus 8. Okay, and then FOIL it. Okay, so 3x times 3x is 9x squared. 3x times minus 8 is minus 24x. -8 times 3x is -24x again. And -8 times -8 is positive 64. And then we combine like terms. The -24's will go together to make -48x plus 64. And there's our final answer there. Okay. Number 4, square root of -200. Anytime we take the square root of a negative number, we're going to pull out a -1 and leave the positive part behind, like this. Okay? What is the square root of -1? I. And then we're going to simplify the square root of 200. Okay? What's a perfect square? Well, first of all, let's check and see. Can I just square root 200?
Yes, you can.
You can, but you get this nasty decimal. So that's not helpful. We need to like figure out perfect squares that divide out of 200. So what's a perfect square that divides 200? Right, 100, right? 200 divided by 100 is 2. So this root 200 is the same thing as root 100 times root 2. What is the square root of 100? 10. So we end up with 10i times the square root of 2. And that's our final answer right there. Okay? So 10I square root of 2. Questions on any of that? No? All right, let's keep rolling here then. Number 5, okay? X squared equals 4x. It's quadratic. We want to make sure, whenever we want to solve a quadratic equation, it needs to be equal to what?
Set it equal to 0.
0. So we'll subtract 4x from both sides, and we get x squared minus 4x equals 0. Okay? When we want to solve a quadratic, we could go straight to quadratic formula if you want to. Okay, but let's try factoring here. In this case, we can factor out a GCF. Yep. Always check to factor out a GCF first. What can we factor from both of these terms here? An x. And we'll have an x and minus 4 left over here. See that? Okay? And then we can set each one of these two pieces equal to 0. So set x equal to 0, set x minus 4 equal to 0, and solve. So, well, that's already solved. And this one we get just x equals 0. So yeah, 0 and 4 are our two solutions there. Okay? However, if you have your graphing calculator here, anytime you have any equation that you need to solve, and you have your graphing calculator, what could you do? How can you use your graphing calculator to solve any equation you ever come across?
Oh, graph both sides.
Graph both sides and locate where they
Intersect.
The x coordinates where they intersect. So graph the left-hand side, graph the right-hand side, find the two points of intersection. The x coordinate will be 0, and the other x coordinate will be 4. It's that easy. Please, folks, don't lose points there because you didn't bother using your graphing calculator. These should be easy points for you. Okay? Same thing for number 6. You could do the same thing that Bobby just described. Graph the left-hand side, graph the right-hand side, find the point of intersection. Let's go ahead and do this by hand, though. So again, quadratic equation wanted to be equal to 0, so we'll subtract 24 from both sides. Okay? I'm looking for two numbers that multiply to make negative 24, but add to make 3. Multiply negative 24 and add to make 3. It's impossible! It does not factor. So that means we're done, right?
No.
No. We're going to use like the quadratic formula here. All right, folks, you'll need to use the quadratic formula here. So x equals. Do I expect you to memorize the quadratic formula?
No.
No. But you do need to know how to simplify it. So negative b plus or minus the square root of b squared minus 4 times a times c.
The pop goes the weasel, Matt.
Yes. If you want to sing it to yourself, you can do that. Okay? We simplify the thing in the square root there. So let's see, it'll be 9 minus 4 times 1 times negative 24. Get 105. So I get negative 3 plus or minus the square root of 105 over 2. Now you then check to see if you can simplify that square root at all, but I don't think we can simplify this 105 with anything that's a perfect square. Yeah, I don't think so.
So that's the final answer.
So that's our final answer. Yep.
Square root of 105 over 2.
Yep. This is the best we can do. So there are two solutions. Negative 3 plus the square root of 105 over 2. Negative 3 minus the square root of 105 over 2. Okay? Questions on any of that? And of course, you can use your graphing calculator here. The graphing calculator will give you decimals, though, right? It's going to convert this square root to a decimal and give you a decimal answer. But, you can still use it to help you. All right, number 7. How many real solutions does this have? How many solutions? That means we want to use a discriminant. What part of our quadratic formula is a discriminant? What part of the quadratic formula is a discriminant? Tyler? Yeah, the part in the square root there. So it's going to be b squared minus 4ac. So Christian, here's where you were trying to do earlier. Okay, this is where you want to use it because you're just trying to find how many solutions there are. So 5 in for the b, 1 in for the a, 7 in for the c. And we'll simplify here. So it's going to be 25 minus 28. We get negative 3. When you have a negative discriminant, how many solutions is that? No real solutions. Okay, that's 2 imaginary. 2 non-real solutions. Okay? All right, number 8. Solve the equation again. Man, these are getting kind of repetitive, aren't they? Okay, so we could look for two numbers that multiply to 41 and add to -6, but they don't. Folks, I promise we have 6 minutes left. You will get to class on time. I promise. I will stop before the bell, but give me a few more minutes if you don't mind. Okay, I promise it'll be worth your while. Okay, I will not go right to the bell. I will stop. Okay, but please don't start packing up just yet. Okay, we'll use this the quadratic formula here. You could also use your graphing calculator. Graph the left-hand side, see where it equals 0. Right? Use the 0 command. Anyway. So negative b, which is -6, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Okay? So you get positive 6 plus or minus. And then when I do that math right there, okay, I get negative 128. Okay? Square root of a negative number means we're going to be using what? We're going to have I, right?
6 plus or minus.
So it'll be root -1, root 128. So it'll be I square root of 128 over 2. And then you look for perfect squares to divide 128. I think 64 is the biggest one. So we'll just divide 64 there. So I root 64 root 2 over 2. What is the square root of 64? 8. So we get 6 plus or minus I times 8 root 2. All over 2. And then we can divide the 6 and the 8 by 2 there. We get 3 plus or minus 4I root 2. All right, let me do one more and then we'll stop. Okay, one more and then we'll stop here. All right, so turn the page there. Okay, turn the page there. We'll look at number 9 and then we'll stop. Okay? All right, number 9. Find the average rate of change. We want to find the average rate of change. That's the same thing as finding the slope. All right, I tell you right there. You can find the slope 2 ways here. Option 1, use the slope formula. y2 minus y1 over x2 minus x1. We have the x-coordinates right there. It's 10 minus 2. The y-coordinates, you have to look at the graph here. So at x-coordinate 10, the y-coordinate is 22. And at x-coordinate 2, the y-coordinate is 6. So we'll get 16 over 8, which implies just plain old 2 there. Another option you have here is since the points are on your graph here, you can just count. Like literally count the rise over the run between the 2 points there. Right? The rise here will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh boy, I missed one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And the run will be 1, 2, 3, 4, 5, 6, 7, 8. 16 over 8, 2 again. Okay, so you can use your slope formula there as well. Or you're counting the slope. All right, we'll stop there. I'll finish the rest of these up tomorrow. I should have left myself more time. Alrighty, folks, so let's go over this review here. Finish things up. All right. So we left off on the previous video on number 9, and I'm going to try and stitch the 2 videos together. So it'll be one video, okay, rather than 2 videos for you. Okay. So number 9, we left off average rate of change, right? That is something we should recognize as the slope, right? You have 2 ways to do it. You can calculate the slope between these 2 points, or you can also count the slope as well, rise over run, right? Okay. Let's skip on here to number 10. Number 10, which of the following 2 functions, f of x or g of x, has the greater maximum within -8 to 0? So this is an interval. These are x values here. Okay? And so when you look at our graph right here, okay, you can kind of, it's hard to see, but I'll try and zoom in here some. The scale is counting by 2s, 2, 4, 6, 8. 2, 4, 6, 8. So from -8 to 0, that means we're looking from right here to right here. Okay? What's the highest y value between -8 and 0 in this interval here? What's the highest y value you see? It might be kind of hard to see there, but again, we're on number 10 there. Yeah, maybe 4. Okay, and maybe even a little bit less than 4. I'd say maybe 3 would probably be a little bit better. So we'll say like 3 or 4 here. Okay? But I think 3 is the better one, is the more accurate one for sure. All right, now let's take a look at this one. Okay? Now, how can we quickly see a graph of this? How can we see the graph of this real quick? Yeah, just graph it. Just graph it. Yeah, just graph it, guys. Use your graphing calculators. Okay, so -1/2. Oops. Make sure you always put fractions in parentheses. Okay. Oops. X squared minus 4x minus 8. Okay, we graph it. Oops. Go back to the normal viewing window there. Okay. Now, I know we're on an interval here between -8 and 0, but look at this graph. What is the absolute highest point of this graph? What's the absolute highest y value in this graph? 0. Regardless of the interval, the highest y value here is 0. The highest y value on the interval is like 3 or 4. Which one has the greater maximum? F or G? F does, right. So F is the answer there. Okay? You don't even really need to worry about it. If you wanted to worry about the interval here, one kind of clever way you can deal with that is you can press the window button. Okay, see window button right there? You can adjust your x values to only show you from -8 to 0, right? So x min at -8, x max at 0. Now when I graph it, I see the exact interval that I'm supposed to look at. And again, you can see we only go up to 0. So boom, we're done. To reset your viewing window, press the zoom button. Okay, the zoom button has a bunch of like pre-configured ways to adjust your window, and Z standard puts you back to the normal viewing window there. If you're ever adjusting things and you want to go back. But anyway, f of x is the answer. Okay, number 11. What is the effect on the graph of f of x equals 4x squared plus 6x minus 2 when you add 3 to f of x? So in other words, we're going to take f of x and we're going to add 3. Okay, what transformation does adding 3 on the outside of our function, what does adding 3 on the outside, what does that do?
It's shifting 3 units.
Shifting 3 units which direction? Up. Up, exactly right. So it's just letter C. Okay. It's the same idea here we had in the warm-up where we had the -2 on the outside here. That shifted things down 2. When you add 3 on the outside, it shifts things up 3. Even if it's not in our normal vertex form here, okay, if I just add 3 to a random function, it will shift it automatically up 3. Okay? All right. Number 12, what is the effect on the graph of 4x squared plus 6x minus 2 when you multiply f of x by 3? So in other words, it's 3 times f of x. Well, what does a number in front of our function do?
It stretches it.
It stretches it. Right, exactly. It's going to stretch it. Now, if you want to take a look, another thing you could do here, I guess I should have mentioned, you could also put this in your graphing calculator, right? Put the original function, 4x squared plus 6x minus 2, right? And then I'll do 3 times 4x squared plus 6x minus 2. Okay? So I'm going to compare the original function and 3 times the original function, right? Because that's what it says, multiply f of x by 3. So when I graph it, there's the original function. And there is 3 times f of x. And you can see that stretch, but notice they both have the same zeros, right? They both cross the x-axis the same place. So, same zeros, different vertex, right, is our answer.
The answer is B.
It is B. Mm-hmm. You could have done the same thing here for number 11, by the way. Graph the original one, and then graph the original plus 3, and you'd see that shift as well. Okay? Number 13 asks us to sketch the graph of the following inequality. So again, you have a couple options here to sketch the graph. You could use x equals -b over 2a to find the vertex. So that'll be -2 over 2 times 1. So -1 is our x-coordinate for our vertex. And I'll plug in -1 here. So we'll get -1 squared plus 2 times -1 minus 8. Okay, and then simplify here. So we get 1 minus 2 minus 8, so -9, I think.
Yep.
Yeah, okay. And so then we get the point -1, -9, and then you can create a table, put -1, -9 in the center, and then fill in the rest of the table, put like -2, -3, and then put 0, and then 1, and then you can use your graphing calculator to help you fill in the table. Or we can go ahead and go straight to our graphing calculator right off the bat. So clear out your y1 and y2, and just graph this thing. X squared plus 3x minus 8. Okay, hit the graph button. Okay, there's our graph. You can press second trace if you want to get the minimum here, which is the vertex. So go to the left of the minimum, hit enter, go to the right of the minimum, hit enter, and then down to the minimum and hit enter. And you can see Did I mistype something? X squared. Oh, plus, I did 3x. I was going to say, I did not get the same thing that I calculated. There we go. Okay. So anyway, second trace, minimum, go to left of the minimum, hit enter, right of the minimum, hit enter, and then in the minimum, hit enter. So there it is. -1, -9. Again, you set slight miscalculation there on the calculator's part, the rounding error on the calculator's part. It should be -1, -9. Okay, and then you can go to your table and get more points. Okay, and you can just graph it. I'm going to very roughly sketch it. You guys will need to be more accurate for this, but just for our purposes here, because I don't want to take too much time here. When I go to connect the dots, what kind of line should I draw? Solid or dotted, according to my inequality there?
Dot.
Dotted, right. So again, just a rough sketch here. It'll look something like this. All right? And then when we have an inequality, I also need to shade. Am I going to shade above my graph, or am I going to shade below my graph?
Below.
Below, because this is what inequality right here?
Less than.
Less than. So we're going to shade below outside. Okay, so just like this. Okay? And there's our answer. Again, you guys can use your table there to help you when you put your graphing calculator. All right, turn the page. Number 14. Which of the following equations is graphed below? Okay. Wow, look, these are all in vertex form here. So our vertex is at 4, 5, which means we've shifted right 4 and up 5. So for example, I can eliminate A and B because they both have a shift down 5. So it cannot be A and B. Okay? And it's between C and D. It is C because we have a shift right 4. Also, what gives it away? The -3 gives it away. Because this graph is concave down, right? So we need a negative as well. So you can actually use both the -3 and the -4 there, or the -4 there to help you. That can't be D. Okay, so there you go. And again, what's another way you can use your graphing calculator? Graph each one of these 4 and see which one matches your graph right here. Right? Just graph in your graphing calculator, see which one matches. Easy. All right, number 15, solve this system. Graphing calculator. Okay, type in x squared minus 5. Type in 3x minus 7. Graph it. Okay, where are the solutions for this system going to be? Where the graphs what?
Where they
Intersect. So to find the intersection point, second trace, and go down to intersect. Okay, and then go close to the point of intersection. Looks like it's right there. Hit enter, enter, and then enter again. Boom. 2, -1 is your solution. Okay. An alternative way to do it without the graphing calculator is to set these two things equal. They're both equal to y. That means they have to equal each other. Okay. Then move everything over to one side. +7 will be +2 equals 0. And then factor and solve. Okay, this does factor. It factors to x. Did I do that right? -3x?
Yeah, you did.
I think there's 2 points of intersection here then.
There are.
Yeah, and then 1, -4 is another point of intersection. There you go. I missed the other one. Sorry. Okay, so yeah, because this factors to x -1 and x -2. Okay, and so you get x equals 1 and x equals 2. Then you have to plug the 1 and the 2 back into one of these equations to get their matching y values, these two answers right there. Right. 16, which ordered pair is a solution to the system? Okay, this one also should be pretty simple. We just got to look at either this point of intersection or this point of intersection. We have the point -3, 5. Let's see, do I have -3, 5, -3, 5? Hey, -3, 5. There's our answer. Okay, do I have the point 1, -3, 1, -3, 1, -3? Nope, exactly right. They only ask for which one of these ordered pairs is a solution. Okay. Number 17. How many solutions does the following system have? So again, you have a couple options here. You could just solve each of these for y and then graph, or you could use substitution or something like that too, and then get the discriminant. You kind of have some choices. I'm going to say, let's just, for the sake of time here, let's solve this bottom one for y so we can graph it. Okay, what do I need to do here to get the y by itself? Subtract x from both sides. Okay, so we get 2y equals -4 minus x, and then what should I do now to get the y by itself? Divide it by 2, right. I'm out of space, I'll go up here. And so we'll get y equals -2 minus, there's a 1 in front there, 1 divided by 2, so -1/2 x. So I'm going to graph this. I'm going to graph this and see how many solutions we'll have. So, clear. x squared minus 6x plus 8, negative 2 minus 0.5x. Or maybe I should use, yeah, let me do it this way. There we go, okay. Graph it. There's the parabola. There's my line. How many solutions does this system have?
No real.
0, no real. So I'm just going to put 0 there. 0 real solutions. It's got 2 imaginary solutions. Okay, 0 real. Okay, easy, easy, easy. All right. 18. Does anyone need me to refresh your memory about how to do 18? Anyone want to see me do 18 again? Yeah, with the calculator. That's what we're going to do, is the calculator. Yep. Okay. So in the calculator here, you're going to, and I'll just, this will be recorded too, so you can recheck yourself. You're going to use a matrix, right? So you want to make sure all your x's, all your y's, all your z's, your equal signs, and your numbers are all lined up. Okay? They need to be in the same order. If they're not, you move things around, so they are in the same order. Then you're going to go into, second x negative 1. So matrix. Okay, the matrix command right there. Second x to the negative 1. We're going to enter the matrix here. Anyway, 3 rows, 4 columns. So 3 by 4 will be your dimension here. And it's going to type in the coefficients. And you see I already have them typed in. 2, 1, negative 1, and then the negative 1, which is equal to. Right? And then those should be negative 3, 2, 2, 9. Right? See right there? Negative 3, 2, 2, 9. And that's what I've got right here. Negative 3, 2, 2, 9. And then same thing for the bottom one. 1, 1, negative 1, and then 0. Okay? At this point, you quit back to your home screen. Go back into matrix again. Now we're going to do some math. And we're going to go down to RREF. Row reduced echelon form. Where do you want to do it? You have to go matrix one more time and tell the name of the matrix you want to do RREF to. And there are your answers. Negative 1 is x, 2 is y, z is 1. Okay? So there we go. All right. Number 19 next asks us to solve the inequality. Select one. So again, we can graph this using our graphing calculators. You can also use factoring too here. So this thing does factor. It's x, let's see here, minus 6 and x plus 2 when you factor it.
Yeah.
Okay, so that means you get x equals 6 and x equals negative 2. You can then use a number line, put negative 2 on it, and then 6, and then test numbers in each interval back in the original inequality. Okay, so pick like negative 3 for this interval, pick like 0 for this interval, and pick like 7 for this interval here. And you're just going to plug each one of those back into the inequality and see if it makes the inequality true or not. So let me just show you an example of that. If I plug in 0, 0 squared is 0, minus 4 times 0 is still 0, minus 12 is negative 12. Is negative 12 less than 0?
Yes.
Yes. So we're going to shade this region here where the 0 worked. Okay? Open circle at the negative 2, open circle at the 6. Another way to check this is using your graphing calculator. If you just graph the quadratic here, oops, I'm blocking it, there we go. X squared minus 4x minus 8, 12, sorry, and graph it. Okay? You can see where it's less than 0, right? The x-axis is 0, so where is it less than 0? Between negative 2 and 1, 2, 3, 4, 5, 6. Between negative 2 and 6, which is exactly what we got right here. So here's the one for between negative 2 and 6, right there, letter C. Between negative 2 and 6. Okay. Number 20 can be solved in a similar fashion here. We want to see when is x squared greater than or equal to 16, which you can actually rewrite as when is x squared minus 16 greater than or equal to 0. So again, I could graph this. X squared minus 16, graph it. Okay. When is it greater than or equal to 0, right? When is it bigger than 0? It's at these tails right here. It's for x values that are less than negative 4, right? It's above the x-axis. And for x values greater than or equal to 4, it's above the x-axis. So it's going to be this one right here, C. Okay? Less than or equal to negative 4, the graph is above the x-axis. Greater than or equal to 4, it's above the x-axis. Questions on those inequality ones at all? Any questions before we move into the free response questions? Okay. So far, so good? All right. Mike, do you not have your review paper? Oh, no. Well, you'll have the video at least. You want another copy in the meantime or something?
Yeah, sure.
Okay. Just follow along here. This is my last one. Oh, okay. Just follow. Okay, moving on. We saw a problem just like this last Friday, right? The garden. Okay, this one's a rectangular garden. So, and these are the dimensions for that rectangular garden. Our friend wants to determine the area of this garden. How do you find the area of a rectangle? What do you do? Length times width. So it'll be, in this case, it'll be a equals 3x plus 1 times x plus 1. Okay? Your calculator will not multiply this out. If you type in 3x plus 1 times x plus 1 in your graphing calculator, you're going to get some random number here because it's going to depend on whatever x value is typed into your calculator. We don't need an answer for a number here. Our area is going to be in terms of x. So we need to multiply this out by hand. Okay? So FOIL, right? 3x times x, 3x squared. 3x times 1, 3x. 1 times x, 1x. 1 times 1, 1. And combine like terms. So 3x squared plus 4x plus 1. And there's our area, okay, in terms of x. That is showing our work, right? Letter B, as friends tend to do, he has changed his mind and wants to double the base and decrease the height by 2. Okay, so which one of these measurements is the base? X plus 1. So the new base, when you double something, what does that mean?
Means you put a 2 in front of it?
Yeah, so it's not square, it means you multiply by 2 or add it to itself. So 2 times the parentheses x plus 1, which just gives us 2x plus 2. So there's our new base. And then the new height, okay, there's the old height of 3x plus 1. If I want to decrease the height by 2, what math should I do to decrease by 2? Subtract 2. Okay, and again, just combine like terms. We'll just take the 2 away from the 1 there, so we get 3x minus 1, because positive 1 minus 2 is minus 1 there. Then it says, determine the area of the second garden in terms of x. So just the new garden area will equal 2x plus 2 times 3x minus 1. And again, FOIL it out. So 2x times 3x, 6x squared, that's right. 2x times minus 1, minus 2x. 2 times 3x, positive 6x. 2 times minus 1, minus 2. Okay, combine like terms. And there it is, 6x squared plus 4x minus 2. Okay. Pause for drink break. Unpause. Letter D. For what values of x will the area of the two gardens be the same? So what two gardens? The new one and the old one, right? So we're going to set them equal. Be the same means they have to be equal. So we'll set 3x squared plus 4x plus 1 equal to 6x squared plus 4x minus 2. Okay. Anytime you want to solve an equation and you have your graphing calculator available, what's one option we could do to solve this equation? Graph the left-hand side, graph the right-hand side, and find the points of intersection. You specifically want the x-coordinates for the point of intersection here. If you don't want to use your graphing calculator because you're miswitted, that's easy mode. All right. So, well, then to not use your graphing calculator, you want this to be equal to 0, right? Anytime you want to solve a quadratic equation, you want it to be equal to 0. So I'll subtract everything over to the one side here. This will all become 0. 6x squared minus 3x squared is 3x squared. 4x take away 4x, gone. Negative 2 minus 1, negative 3. This one's actually not that hard to solve. You can just add the 3 back over now. Because we just have the x squared there, we can actually use square roots. So we get 3 equals 3x squared. Divide both sides by 3. You get 1 equals x squared, and then square root both sides. X equals plus or minus 1. Now, in the context, does positive 1 make sense in the context for our garden here? Would a positive 1 make sense for x? Yeah,
Positive
right?
1.
Yeah, 1 plus 1 is 2, 3 times 1 is 3, plus 1 would be 4. So 2 by 4, no big deal. Does a negative 1 make sense in the context?
No.
Why not?
You can't have a negative space.
Well, so yeah, the x equals -1, that could, yeah, we have a negative dimension here. Sorry, I see what you're saying there, Luke. Yes. We have a negative dimension here, we have a 0 dimension here. That garden wouldn't exist. So we're going to throw out the -1, and only x equals 1 will be our solution there, because -1 does not make sense in the context. It wouldn't make a garden. Okay, a garden, that does not make. Questions on that free response question? Okay, so on Friday we saw a garden question with, determine the area of the garden in terms of x. Your friend changed their mind and changed the 2 dimensions. You found the new area for that new garden, and then you found when they were equal. These are the exact same questions you saw on Friday, so what do you think you can expect to see tomorrow? The exact same questions. Different numbers, right? But same kind of scenario, okay, guys? So you can be successful in this. You just got to, understand what you're supposed to do, and that's it. 22, okay? On Friday, it was a baton twirler, okay? Today, it is a batter, okay? Hitting a baseball at a height of 3 feet above the ground with initial velocity of 56 feet per second. The height is described by this function, right? The height of the baseball. T is the number of seconds. H of t is the height. Okay, so we're going to graph this thing on the graphing on our grid, but we're going to use our graphing calculator to help us, of course. So -16x squared plus 56x plus 3. Don't use t's, even though I know they use t's. You have to use x's in your graphing calculator here for this one. Okay, so we graph it. And oh man, it does not fit. So we need to be able to adjust our window here. Which way do I need to adjust my window to see more of my graph? Do I need to shift up, left, right, or down? If I want to see more of my graph, which way should I shift? Up, right? We want to see up more. So if I press the window button here, I want to adjust the Y max, because that adjusts how high my graph goes. Let me try 20. Oh, I just did 2. That's really bad. 20. Okay, and let's see how that looks.
Still not good.
Better, but I got to go higher. So let me try 40. Ooh, better still, but not high enough. So let me try 60. There's the whole flight path of the ball. So you can see here, I did not adjust my x values. So for my x values down here, these t values, okay, you can count by ones. I'm actually going to count by every other box being 1. So this will be 0. That'll be 1, 2, 3, 4, 5, like that. What should my x-axis be? Oops, what should my x-axis be labeled here?
Seconds after ball.
Yeah, it's time in seconds. And if you want to put the rest of that, like seconds after the ball was hit, that's fine too. How about then for the y-axis? Remember, I had to graph up to 60. So would counting by ones here be a good idea?
No.
Probably not. Let's see if we can get away with counting by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. 30 is not quite high enough either. What would maybe be a good number to count by?
Try counting by
5s?
4.
Okay, or 4s. I'd say 5s or 4s would be a good idea here. 4s are nice because it's easy to figure out, if you have numbers that aren't divisible by 4, it's easy to kind of figure out what they are, but 5s are easy to count by 2. So let's just do 5s. 5, 10, 15, 20. But you have some choice there. So if you count it by 4s, that's great too. Okay, I would probably count by 4s myself when I did this one, but that's because of the way I like to graph things. All right, and then what should the y-axis label be?
Height in feet.
Height in feet. Okay, please don't forget these labels, folks. It tells you to label them, okay? That's just more than the numbers. You need to put the actual labels for the axes. This gives you points, okay? Without even getting the graph right, if you put these down, you get points for this, okay? So please don't, screw yourself over by not doing that. All right, the next thing we're going to do here is we're going to pick some points. I'm going to go to the table to help us out. So at 0, I should be at 3. So 0 is 3, so maybe right there. And then at 1, I'm at 43. So 43 is about right here, we'll say. At 2, I should be at 51. And then at 3, 27. Okay. And then at 4, we're at a negative 29. All right. Excuse me here. I am going to take some time here and figure out the vertex here. What command can I use in my graphing calculator to figure out what the coordinate of this point is? You know what I can press here to get that coordinate there? for the vertex?
That's a stat value.
So it's going to be second trace, and then which of these commands do I want to use to find that point? Maximum. Okay, we don't have the vertex, and there's no other graph for us to intersect with there, Luke, so we wouldn't use the intersect because there's no other graph. But we were going to use maximum because it's the highest point that we're trying to find in this case. So make sure you're to the left of your vertex, hit enter, then go to the right of the vertex, hit enter, and then go towards the tippy top and hit enter. And there it is. And you're going to have to round this. It's like 1.75 comma 52. So here's 1.5. 1.75 would be right here, and then up to 52 would be like right there. Just above the 51 there. Okay? And then just kind of connect the dots. Okay, but this is the highest point. Okay? And it goes back down like so. Okay? So there's the graph. If you want to get more points, you can, okay? You can just like plug in some more points. Like I could have plugged in 3.5 there and see what number I get. But anyway, just for the interest of time, we need to keep going here because I got 5 more minutes. Okay? How high is the baseball after 3 seconds? Well, that's easy. You can go to your table. 3 seconds, 27 feet. So h of 3 equals 27 feet.
So you can just look at your calculator for
Yep. You could also plug the number 3 into the equation here and then just simplify. It should also give you 27. It says round your answer, but obviously it's if applicable.
Will you take off points if we then say h of 3?
Nope. If you just said 27 feet, that's quite all right. Thank you for asking that question. I just put that there so you guys could also see it's just plugging 3 into h. All right. What's the maximum height? We just found it.
1.7.
So the maximum height, you only need to give the 52 for the height. Okay, so 52 feet is the maximum height. Again, that's using your graphing calculator. Find the maximum there. After how many seconds does the baseball reach its maximum height?
1.75.
That's the 1.75 x coordinate there. Okay, so please be careful that you give the correct answer in the correct location. If the baseball is caught at a height of 6 feet, at what time is it caught? So in other words, we want to know when does h of t equal 6? Okay, so I'll go to my graphing calculator here. I will graph 6. So there's the height of 6. Now there's 2 places on my graph where that baseball intersects 6. Which place should I select for where it is caught? Probably this right one, right? Now granted, you can always say, well, Mr. Witt, like the batter could have like foul tipped it and the catcher like caught it 6 feet in the air, or something like that. Because it's like really quick, or something like that. And yeah, that can happen, but most likely the ball is going to go up, reach its maximum height, and then come down and get caught, right? So we're going to go for that second point there. All right, but if you really wanted to argue with me, I guess I could see that argument. Okay, so for your intersection point, go near the point of intersection. Again, we're using the intersect command. Okay, hit enter, 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 and voila. So at what time? Simplify all square roots, or we're not going to use square roots here, we're just going to use the calculator. So we'll round here to like 3.4 seconds. Okay. State a reasonable domain of the function in context. So domain describes the what coordinates?
X coordinate.
X. Or in this case, our domain, our x values are really what variable? In this problem, we don't have x's. What do we have? T's. So we want to talk about time. Okay. What is a reasonable amount of time? What is the smallest amount of time we should probably start talking about this problem?
0.
0, right. So we're going to start at 0. Okay, and then looking at our graph here, would it make sense to continue our domain to infinity?
No.
No. Where should we probably stop talking about our domain?
1.75.
1.75 is the peak, but the ball still will fall down after that. Where would it make sense to stop talking about the baseball? When it hits the ground. And we got to figure out this number right here, where it hits the ground. So we'll press second trace and use the 0 command because it's where it's the 0, right? So make sure you're to the left of the 0. Make sure I'm on my graph there. Hit enter. Go to the right of the 0. Hit enter. Go back to the 0. Hit enter. And about 3.55 seconds. And we'll put a square bracket around that. Okay? Hang on there, Mike. I know you want to pack up, but I'm going to keep going here. All right? I promise you guys will get time to be done here. We've got a few more seconds. A few more minutes, I mean. All right? So that's a reasonable domain. From where it's hit at time 0 to when it hits the ground at 3.55. If you said at 3.4 there because that's when it's caught, I understand that as well, and I'd accept that answer. Okay? All right, 23a, you guys had to do that one for homework. This is where you use that quad reg. All right, so just put in your 4 points here and use quad reg and get this. For the equation of g of x, be careful here. G of x is not quadratic. Selected values of linear function g of x. So in this case, you would use lin reg. You can type these numbers into L1 and L2 and you would use lin reg there. Okay? So I'll do that here real quick. Guys, I promise. -4, -1, 2, 5, 7, 1, -5, -11. Count, lin reg. You should get y equals -2x minus 1. What are the coordinates of the points where these two functions intersect? Again, just graph. Okay, and find those points of intersection. Let's see if I can do that here real quick. -x squared plus 4x plus 5, -2x minus 1. Intersect. Okay. Woof. I missed my negative. Guys, I promise you'll get out. Why are we all standing up here? I promise. You guys do okay. Thank you. If you don't, I promise you'll get out. All right, you have plenty of time. All right, here we go. Last one. Okay, so you have to round these, of course. Okay, it says round your answer to the nearest hundredths. There's one intersection point here. There's one down here. And then lastly, which function has a greater average rate of change? Which means you have to find the slope. So you have to find the slope from here to here, -1 to 2, and the slope from here to here, -1 to 2. Use your points and compare them. All right? That'll be it. All right. Bye, guys. Have a good day. Please study some tonight. Use the video I'm going to post too, okay? Yeah, make sure you have batteries.